Okay, so let's talk about double displacement reactions. Now, in this type of reaction, what typically happens is that you have two compounds exchanging partners with each other to produce two different compounds. All right? So, basically, if we're looking at it from a hypothetical sense, imagine you have a compound AB reacting with a compound CD. What is happening in this type of reaction is you have the A switching partners with D. So you're going to end up with A replacing C, as shown here, and end up being combined with D to form AD. And B itself will displace D and end up being combined with C to form CB. All right, so that's basically what happens. Now, typically A and B would be ions in the vast majority of cases. In fact, I can't think of any situation where that's not the case. So typically A, B, C, and D would be ions, and there's an exchange of ions, and you end up with your products. Now, typically, when these reactions occur, we have these happening either the formation of a precipitate, or the release of gas bubbles, or the release of heat, or finally the formation of water. Typically, these are what we would observe whenever we have a double displacement reaction. So, we're going to look at a few examples of these reactions. The first of which is acid base neutralization. And this is a reaction where you have an acid reacting with a base to form salt and water. So the acid in this case is hydrochloric acid, the base is sodium hydroxide, and you can clearly see the exchange of ions taking place where the hydrogen will be replacing the sodium, and as a result will be combining with the OH to form H2O, and at the same time you have the chloride replacing the hydroxide, and the result will be the formation of NaCl, sodium chloride. So that's what happens in the neutralization reaction, the reaction between an acid and a base to give a salt and water. Here's another example, the reaction between sulfuric acid and sodium hydroxide. In this case, again, the hydrogen will be replacing the sodium to form water, and the sulfate will be replacing the hydroxide, and the result of that would be the formation of the sodium sulfate. All right, so acid-base neutralization is one example of a double displacement reaction. Now, here's a reaction where you have the formation of a precipitate, the reaction between silver nitrate and sodium chloride to form silver chloride, which is a solid, a precipitate, which is formed out of the solution, and NaNO3 would be the byproduct. So again, you can clearly see the double displacement taking place, the exchange of ions where the sodium is replaced by the silver to form the silver chloride, which ends up as a precipitate, and the nitrate replaces the chloride, and the result would be the formation of the sodium nitrate. Here's another example, lead nitrate reacting with potassium iodide. Again, the lead in this case would be displacing the potassium, so the lead would end up being combined with the iodide to form lead 2 iodide, and the nitrate will displace the iodide to form potassium nitrate. So that's another example of a double displacement reaction. Here's another example, the reaction between a metal oxide and an acid to produce salt and water. So it's very similar to the neutralization. The example being used here is copper 2 oxide reacting with nitric acid to form copper 2 nitrate and water. The copper will be displacing the hydrogen to form the copper 2 nitrate, and the oxygen will be displacing the nitrate to form the water. In this case, the reaction between calcium oxide and hydrochloric acid, again, same thing is happening. The calcium displacing the hydrogen to form calcium chloride, and the oxygen displacing the chloride to form the water. All right. So that's another example of this double displacement reaction. Now here's an example where a gas is formed, and this is a reaction which results in the formation of this gas, which is very poisonous. You don't want to be in a room filled with hydrogen cyanide. And in this reaction here, the reaction is between sulfuric acid and sodium cyanide. And in this case, again, you can see double displacement taking place where the hydrogen is displacing the sodium to form the hydrogen cyanide, which is a gas, and the sulfate is displacing the cyanide to form sodium sulfate, which will remain in an aqueous solution. And here's another one, the reaction between ammonium chloride and sodium hydroxide. Now this one is a bit different because the double displacement reaction taking place here will result in the formation of sodium chloride, which is in an aqueous solution, and ammonium hydroxide. But the thing about the ammonium hydroxide is that it will undergo itself decomposition to form ammonia, which is a gas, followed by water. So there are two types of reactions that are taking place in this particular reaction. The first reaction is a double displacement reaction, which results in the formation of sodium chloride and ammonium hydroxide, and then the ammonium hydroxide itself will undergo a decomposition reaction, the result of which would be the formation of ammonia. All right? Okay, so the gas is formed indirectly, in other words. All right, now that's the end of this discussion, but I'm going to post another video where I'll be discussing combustion reaction, which is a different type of reaction that I think it's important that you have an understanding of. All right? Okay, so until next time.